All right, we're going to go over section 1.6, other types of equations, which is the learning objectives are going to be, we're going to look at radical equations, equations with rational exponents, and some modeled equations. So a radical equation is an equation in which the variable occurs in a square root, cubed root, or any other. So in other words, this is a square root of 9, square root of x equals 9. All right, we're going to go ahead and we're going to solve. So what I'm going to do is, this example is in the book, but I'm going to go ahead and I'm going to start with the practice problems first, because you can look at that one in the textbook, and I'd like to go over these. So if you look at the rules, the first thing it says is that we need to arrange it so that one radical is isolated on one side. So looking at number 1, what that means is that this just has a radical on this side. If you notice over here on number 4, we've got a radical, and then we've got this -2. So we're going to have to do something a little different on this one. So our radical is isolated. So the next thing we're going to do is that we're going to raise both sides to the equation to the nth power. So because this is squared, we are going to square both sides. So we're going to put this in parentheses. I'm going to go 2x plus 3. We're going to square, and if we square one side of the equal sign, we need to square the other side. All right? So what happens is that a square root and a square are inverses of each other, so they cancel each other out. So this is now 2x plus 3 equals 16. And so now we're into our solving skills, where we're going to subtract 3 from both sides. And so then we end up with 2x equals 13. And then we're going to divide both sides by 2. So we have that x is equal to 13 over 2. We're just going to leave that as a fraction. So we do need to check our answers, because sometimes we may get 1 or 2 answers and they don't work. So you can check with your calculator, or you can put it back in here. I'm going to do this first one on a check, and the rest of them we'll either do by using a calculator, or we'll do it mentally. So here, if we do this, this cancels. 13 plus 3 is 16. The square root of 16. Does the square root of 16 equal 4? Yes, it does. So it checks. So our answer is 13. X equals 13 over 2. All right. So let's go to number 2. We have the square root of x minus 5 equals -4. So we're going to go ahead. Our radical is isolated, so we're good. So we can square both sides. So we have x minus 5 squared equals -4 squared. So now we have x minus 5 is equal to -4 times -4 is 16. Add 5 to both sides. So we have x is equal to 21. So let's go ahead and check this. So if we go and put this in our radical, we're going to replace x with 21 minus 5 is equal to -4. Well, 21 minus 5 is the square root of 16 equals -4. Well, the square root of 16 is 4, which equals -4. Well, that's not true. So this is considered there is no solution. Now, we could have, without doing the work, we could have already said, like, this doesn't work. If we're looking up here, the square root of something equals -4, right there we could have stopped, because we can't have under the square root for the real numbering system is not going to equal a negative. So this is an impossible equation. If it's a fact you don't remember, then when you check it, you're going to end up with a no solution. Oops, sorry about that. With a no solution. All right. So for number 2, it is no solution. All right, moving on to number 3. For number 3, we have here the square root of 20 minus 8x equals x. Notice we still have a radical that's isolated, so we don't have to move anything. But this time it equals an x, so our answer, we're going to have something a little different than we did in 1 and 2. So negative 20 minus 8x, and we're going to square it, equals, and we're going to square our x. So this side is going to have 20 minus 8x equals x squared. Well, we have two x's. We've got an x squared, an 8x, and a 20. So we've right here, we have a quadratic. So let's move everything over to this side. Let's keep this positive. So if we move the 8x over here, that's going to be a positive 8x. If we move this over, it's going to be a negative 20. So we would have x squared plus 8x minus 20 equals 0. Well, there's a couple of ways that we can solve for x here. We could use the quadratic formula, or we practiced with factoring. And so with our factoring, since we have an x squared, we're going to go an x and an x. And because our c is a negative 20, we're going to have to, I'll do it over here, we're going to have to find some numbers that when they multiply, they equal 20. And when they add, they equal 8. So this is the multiplication, this is add. So in other words, if we did negative 4 times 5, well, negative 4 plus 5, well, negative 4 plus 5 gives us 1. So that doesn't work. So how about if we use negative 2 times 10, because a negative 2 plus 10 gives us the 8. So we could go negative 2 plus 10. And then if we use the 0 property, we can go, okay, so x minus 2 is equal to 0. And you may say, what's the 0 property? If I make this parentheses equal to 0, then 0 times any number equals 0. And when I make this parentheses equal to 0, this 0 times anything will give me 0. So I got to figure out what x here and what x here will make this parenthesis equal to 0. So we're just solving by algebra. We add 2 to both sides, and we end up with x is equal to 2. Then if we do x plus 10 is equal to 0, we're going to subtract 10 on both sides, and we would end up with x is equal to negative 10. So we need to check. And to check, I'm going to go ahead, I said we'd do some mental math, but we'll just go ahead and put this minus 8 times 2 should equal to 2. So 20 minus 16 is 4. So the square root of 4 is 2. So what I did is I'm doing the x, I'm letting x equal 2. So I'm putting it back into the original. So this is the 8 times 2, and it equals 2. So square root of 4 equals 2, so 2 is equal to 2, so that checks. So this is a good answer. So now let's put it back into the original equation, all right, where it's negative 10. So this would be, so x is equal to negative 10. This would be the square root of 20 minus 8 times negative 10 is going to equal negative 10. Well, right away from our problem number 2, we know that's not possible, but we'll just go ahead, we'll do the check here. This would be 20 plus 80, which is 100, is equal to negative 10. Well, the square root of 100 is 10, and 10 does not equal negative 10. So this is not a good answer. So we would only have x is equal to 2. Okay? So I'm going to go and let's work on number 4 because that's a different type. So here we have square root of 3x minus 1. Notice that the square root symbol does not go over the minus 2, so it's not part of the radical. So our first step in solving is that this is none of the radical, so we need to move it over here. So that means we need to add 2 to both sides. So now what we have is we have 3x minus 1 is equal to 6. And now we're back to the problems that we've been on, like 1 and 2. So we would need to square both sides. Which would then give us 3x minus 1 is equal to 36. And then we would add 1 to both sides. And we would get that 3x is equal to 37. And then divide by 3, divide by 3. So x is equal to 37 over 3. And then we can check it. And this is a good answer. All right, number 5. Again, this is not isolated. So we need to move our 6 over. So we're going to add 6 to both sides. So now what we have is 2x plus 15 is equal to x plus 6. So from here, we would need to square both sides, and we would end up with 2x plus 15 equals, and this time we're going to have x plus 6 times x plus 6, so we're going to have to FOIL, so this is going to be 2x plus 15 equals x squared plus 12x plus 36. And then from there, because we have a quadratic, we want to move everything to the other side. So we're going to have to subtract 2x, subtract 15. So we're going to end up with x squared plus 10x plus 21 equals 0. And I'm going to let you finish that one out, but I'm going to you should, when you get this, when you check your answers, you should get that x is equal to -3 and -7, but -7 is not a good answer. All right, and if you don't get that when you come to class, I'll ask me about this and we'll go from there. Okay, I'll help you with that. All right. So number 6. Here's our radical. It's not isolated, so we're going to have to go -7, because that's our first step. Then we have square root of 4x is equal to x plus 2. So now we've got a situation over here like with number 5. You're just going to square both sides, and when you get to this one, you're going to end up with that x is equal to plus or minus -2, and when you get this, you're going to find out that neither of those work. So you're going to end up with a no solution, and I am going to let you work that one out. All right, and then let me move that over, and then in class, if you need help with it, then I can help you from there. All right, moving on. So number 7, okay, number 7, same thing, you're going to isolate, but notice that there's this negative here, and we don't want that negative. So what I would do is I would move this whole thing. If we move this to the other side, that gives us a positive, and then move the 1 over here. So you would end up with x minus 1 is equal to the square root of x plus 11. And now from there, you can square both sides, and check your answers and see which one works. On this one, you should get the answer of x is equal to -2 and 5, and you'll get that 2 doesn't work. All right, so then on this one, same thing. When you get to here, you're going to get that the answer is x is equal to 1 and 3, and those are both good answers. All right, moving on. We're going to move on to the next section, which is equations with rational exponents. So with this, rational exponents means that your exponent is a fraction. All right, and there's two ways that you can interpret this. So the denominator, the thing to remember is that your denominator is always your root. Okay? Your numerator, what you can do is you can, depending on how to solve the root, you can either put the numerator right next to your number here, or if it helps, put it on the outside of parentheses. And we're going to do a few where some cases it's better to go like this, and some it's like that, so you can get exposure to both of them. Down here, it says isolate the expression with the rational exponent. This is to solve, and then raise both sides to the equation to the power. So I'm going to show you how to do that. This is if it's an even. So if our numerator is even, then we're going to get two cases. And we'll go through that. If it's odd, we're going to get only one case. Also here, we have to check if we actually have a solution, or if there is actual solutions or extraneous solutions. All right? Okay. So, I went ahead, in your notes, if you looked at this, I went ahead and solved one here for you and did the steps. So we wanted to take x raised to the 3/2 and equals 8. So we got to figure out what this is. So the first thing you're going to do is you're going to multiply the rational exponent by the reciprocal on both sides of the equation. So the reciprocal is, you might have in high school said flipped, okay? So 2/3 and then 2/3 here. So if I was to multiply this out, this would be 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1. So now if you look back on your notes on how this is, you can decipher your rational. So the denominator is always the root. And what I did this time, instead of going and putting 2 to the 8, I went ahead and put it outside the parentheses. You could have done it either way. So what I did is I found the third root of 8. So what same number multiplied 3 times equals 8, which is 2. And then, so this part right here is equal to 2, and then I squared it, which is 4. And 2 times 2 is 4. All right? And I can check it. So I could put in a 4 for x, then decipher. There's my denominator, which is squared, and then there's my 4. I put my numerator outside of the parentheses, so I said, what is the square root of 4? Which is 2, and 2 to the 3rd power is 8. So it's like, all right, this is good. I got the right answer. Woohoo! So the first one that you have here is from example 5A on page 181. So we'll go ahead and I'm going to let you look at that one, and I'm going to work on number 3. All right, so first thing we need to do is we need to, same thing, we want to get x by itself. So we follow the same rules as if this was x squared or something. So I first need to add 12 to both sides. So then I have 6x raised to the 5/2 is equal to 12. So now I need to get this exponent equal to 1, so I'm going to multiply by the reciprocal. So that's going to be 2/5. I'm going to multiply by 2 over 5. But not yet, because I made a mistake. Getting ahead of myself here. All right, erase that. Hopefully you're using pencil. I'm sorry, I need to isolate x, so I need to divide by 6, divide by 6. So x here is 5/2 is equal to 2. All right, so now, all right, now what I need to do is multiply by the reciprocal. So I'm going to multiply by 2 over 5, 2 over 5. All right, so this becomes 1, and this is 2 to the 2/5. So what I'm going to do is I'm going to put a 5 in here because that's my denominator, and put my 2 here. And I'm like, well, I am not exactly sure what the 5th root of 2 is, so I'm going to put the 2 here this time. And this right here, if I go 2 times 2, that's going to give me 4. So x is equal to, what, the 5th root of 4. Well, I don't know, that's going to be a decimal, so this is where you can leave it right like this, but since we have calculators, we can put it in the calculator, and we would get 1.3195507. And let's say that, let's round to the hundredths. So 1.3, so I'm going to round to the hundredths. I'm going to look at 9, that's greater than 5, so I'm going to make this 1.32. And if you put it back in the calculator, it'll get close to 0 because we rounded, but it is a correct answer. Okay? All right. So the next thing we're going to do, next type we're going to do is, what if we have a rational with around a parentheses? Same thing. We're going to go x minus 5. This is going to be 5/2, and we're going to multiply by the reciprocal, because you're like, well, there's an x here and over here in this one you said we needed to isolate. But this is parentheses, so we have to take care of, when you're solving, you're doing PEMDAS, you need to take care of the parentheses first. So this is going to be multiplied by the reciprocal. So we have 32 raised to the 2/5. So this becomes 1. So this is now x minus 5 is equal to, and I'm going to translate this. So the denominator is my root. Here's 32, and I really don't want to square 32, so I'm going to put that 2 on the outside. So now I have x minus 5 is equal to, well, the 5th root of 32 is 2. You go 2 times 2 times 2 times 2 times 2, and then multiplied by 2. So I have x minus 5 is equal to 4. If I bring that over here, I put x is equal to 9. Then I need to check my work, and I can put this in my calculator. I could go 9 minus 5 raised to the 5th halves, and if it equals 32, then it is correct. So that's a check. So this one right here is similar to 4, so I'm going to let you work on that one. The answer you should get here is that x is equal to 13. All right. I guess I could have put that up here, but I'm pretending that you're getting all this work done on that. All right. One more thing in this one is that we have a word problem. Okay. So here we have a basketball player's hang time is in the time spent shooting the basket, and they give us the formula for the hang time. So I'm going to put this here. T is equal to the square root of D over 2. So here it says, when Michael Wilson of the Harlem Globetrotters slam dunk a basketball, his hang time, all right, so his hang time, and they set up here the hang time is T, so this is T, for the shot is approximately 1.6 seconds. What was his vertical distance? And so vertical distance is D of the jump. So I'm going to fill in the answers, and this is going to be, or fill in my numbers here. 1.16 is equal to square root of D over 2. Sorry about that. So I need to isolate my radical first, so I'm going to multiply both sides by 2. And when I do that, I get 2.32, and these cancel, equals the square root of d. And then I'm going to square root both of these. And when I get that, I get 5.3224 equals d. So we can say that his vertical distance is equal to approximately 5.3. And it says round to the nearest tenth of a foot. So that's the tenth right there. Feet. Okay. All right. Then we have one more, and I'm going to let us set this up, and then if you need help, you can in class ask. So this is our equation right here. It says E is equal to 0.2x raised to the 3/2. All right, and it says there are approximately 88 Earth days in the year. So up here, the Earth days, oops, sorry about that. So it says here the Earth days is E. So our 88 Earth days, this is going to be our E. What is the average distance of the Mercury from the Sun? So average distance is x. We're going to set this up as 88 equals 0.2 x raised to the 3/2. And we're going to isolate x, so we're going to divide by 2 on both sides, and I'm not going to say anymore. And you should get the answer of x is equal to 57.8498789, and it wants us to round to the nearest million kilometers, so this will be approximately 58 million kilometers. All right, you guys. I hope this helps. See you in class.